This video is area of regular polygons. We want to apply the formula for the area of regular polygons and calculate the length of the apothem. There's a new word, Pythagorean theorem as needed. Okay, so let's look at this picture. Here we have a hexagon, and so it has 6 sides. So this is a side. This is the center. Now we have a radius. Usually we think of a radius as a circle. Well, if we were to draw a circle that just circumscribed, in other words, just touched each vertex here, you can see that this line here goes from the center and touches the circle. So that is a radius of that circle. It's also a radius of this polygon. Any of these. You could draw any from any of the center to any vertex is a radius. So our new term is apothem, and that is this line right here. And the apothem goes from the center to the midpoint of a side at a right angle. So you see we're going to have a triangle here, and so we're going to use that triangle to measure, find the measurement of the apothem. Okay, let's look next. We define regular polygon. We've done this before, but a regular polygon is a polygon that is both equilateral and equiangular. In other words, all of the sides have the same measure and all of the angles have the same measure. So these formulas that we're going to use is only going to apply to regular polygons. And the apothem is the distance or the length of the line segment from the center of the polygon to the midpoint of a side, to the midpoint of any side of that polygon. All right? So, what is the sum of interior angles of a hexagon? Hopefully y'all remember the formula. N minus 2 times 180. So we have 6 sides. So that would be 6 minus 2, or 4 times 180, which is 720. And then we need the measure of one interior angle. So remember that is N minus 2 times 180 divided by N. In other words, 720 divided by 6, because there's 6 sides, is 120. That means every interior angle in here is 120 degrees. Well, when we draw the radius, let me use a different color. The radius bisects the side. So that's going to make this 60. We draw the apothem, which creates a right angle and bisects the side. So you will see a 30, 60, 90 triangle, and it's going to be created inside any regular hexagon. All right, now let's use that to solve some problems. Let's see. Oh, first let's give you the formula. The area of a regular polygon is half the product of the perimeter of the apothem. So here, this is, the area is 1/2 little a for apothem, capital P is for perimeter. I'm not sure why they give you Pythagorean theorem here, because we should be using special rights. Okay, so we're going to have a 30, 60, 90. So you have to remember here, you're going to have to know your 30, 60, 90. Because in these hexagons, you're always going to have x, 2x, x to the square root of 3. Okay, so in this first one here, they give us the side across from 90 is 12, so that is 2x, so x is half of that, or 6. Now remember, this is half of that side, so that means each side is going to be 12, and the apothem is going to be 6 to the square root of 3. So we just put it in our formula, 1/2, 6 to the square root of 3 times the perimeter. Now if each side is 12, you have to multiply 12 times 6, because there's 6 sides, and you get 72. Now remember, leave this out of your calculator, because we do not want, we want the exact answer. So I'm going to do 72 times 6 times 1/2, or 72 times 3. And that is 216 to the square root of 3. All right. Please pause the video and see if you can do example 2. Hope you paused. But this would be 5. This would be 5 to the square root of 3. So now it is 1/2 times the apothem, 5 to the square root of 3, times the perimeter. Now each side is, this is half a side, so 5 and 5 is 10, and there's 6 of them, so 60. So that would be 150 to the square root of 3. Example 3, same thing. 2x is 24, so x is 12. So the apothem is 12 to the square root of 3. This side is 24, so we have 1/2 times 12 to the square root of 3 times the perimeter. There's 6 sides, so 24 times 6 is 144. And then we're going to multiply 1/2 times 12 times 144. Or 144 times 6 is 864 times the square root of 3. Okay. It's kind of long, so pause at any time. I know I'm going a little fast, but I know it's going to take 2 videos. Okay, here we have a regular quadrilateral, better known as a square. We have our side, we have our radius, we have our center, and we have our apothem. So let's see what kind of triangle that is created here. Well, first we're going to define a regular quadrilateral. It's a 4-sided figure that is both equilateral and equiangular. It contains 4 right angles and is also known, or probably better known, as a square. And the apothem is the radius of a polygon circumscribed circle. In other words, if we were to draw the circle outside the square, like they did here, you can see that the radius goes from the center to the circle, which is also the vertex of the square there. Okay. So if we do the same thing we did before, the sum of interior angles of a regular quadrilateral, n minus 2 times 180, or 4 minus 2, 2 times 180, is 360. And then what is the measure of one interior angle? Well, 360 divided by 4 is 90. So we know that the angles, the interior angles, are 90 degrees. So if we draw the radius and cut that 90 in half, there's our 45. We draw the apothem at a right angle, and you can see that we have a 45, 45, 90 triangle. And hopefully everybody's got this down by now. X, x, x to the square root of 2. Okay? So, let's work these problems. Find the exact area of the regular polygon below. We have a square. They tell us it's a regular polygon, so we know it's a square. And so you should already know that this is 9. This would be 9 to the square root of 2. We don't really need that measurement. If half a side is 9, the whole side is 18. So we have 1/2 AP. So 1/2 times 9 times, what is 18 times 4? That is 72. And that is 324. Okay, example 5. This is one that I hope y'all have got down by now, but let me just draw a picture. 45, 45, 90. When the side across from 90 is an integer, remember we have x, x, and x to the square root of 2. So this is saying that x to the square root of 2 is equal to 10. Hopefully by now you've just memorized that the other side is going to be half of that times the square root of 2. 5 to the square root of 2. 5 to the square root of 2. But if not, let's go through it one more time for those of you that are still. If x to the square root of 2 is equal to 10, and we need to solve for x, we divide both sides by the square root of 2. And we get x is equal to 10 divided by the square root of 2, which is the correct answer, but you cannot leave the radical. So you have to multiply by the square root of 2 over the square root of 2, and you get 10 to the square root of 2 divided by 2, which is simplified to 5 to the square root of 2. So in this picture here, this is 5 to the square root of 2, and this is 5 to the square root of 2. Okay, if half a side is 5 to the square root of 2, the whole one is 10 to the square root of 2. So now we have 1/2 times our apothem times the perimeter. So 10 to the square root of 2 times 4 is 40 to the square root of 2. All right, so now how do we multiply all that together? Well, you're just going to multiply everything. You want to multiply 1/2 times 5 times the square root of 2 times 40 times the square root of 2. Let me show you how I see this. I know that the square root of 2 times the square root of 2 is 2. Okay? I know, and then we can multiply 1/2 times 5 times 40 times 2. I'm going to multiply 1/2 times 40, and that's 20, times 2 is 40, times 5 is 200. Okay, you can put that in your calculator if you want. Just make sure you understand that the square root of 2 times the square root of 2 is 2. So here we're not going to have any square roots in our answer. The answer is just going to be 200. Yeah. Okay. Example 6. Well, I see that the side across from 90 is 3 times the square root of 2. So that's going to make these sides 3 and 3. So the whole side is 6. So 1/2 times 3. And then each side is 6. There's 4 sides. 6 times 4 is 24. So this is just going to be 36. Okay, I'm going to go ahead and stop the video here and make a second video because I don't think I'll get through the whole thing. And next we'll go to an equilateral triangle.